Hey guys, today we're going over chapter 3, section 1, part 2. Now, last time we solved graphically the two equations. Now we're going to start by solving algebraically. What does this mean? This means that you're going to have an equation. You can have an equation, for example, 2x plus y equals 5. And you're going to have another equation that is y equals 7x plus 3, for example. And you're going to substitute one equation into the other in order to solve for the solution algebraically. Now we're going to do some examples and I'll explain how that's going to work. But the steps are listed here. Step 1 is to solve one equation of one of the variables. In this case, I rewrote this one already solved by solving for y. The second will be to plug that y into the other y. So that means instead of y, we're going to have the 7x plus 3. So it's going to look like 2x plus 7x plus 3 equals to 5. And lastly, we would solve for the other variable. In this case, we would add the x's to 9x plus 3 equals to 5. We'll subtract the 3. Then we'll get 9x is equal to 2. We'll divide it by 9. And we get x is equal to 2 over 9. So that's how you would solve, at least for one variable, algebraically. We're going to solve for the other one by plugging that number back in. But I'll go over some examples to show you guys how it works. Okay, here they want us to use substitution to solve for each system. Now, I'm going to solve for y, this second equation. So I'm going to subtract the 2x and I'll get y is equal to negative 2x plus 7. Now I'm going to grab this negative 2x plus 7 and plug it right there into the y. So I'll do 5x minus 3. Then in parentheses, negative 2x plus 7 equals to 23. Then I'll go ahead and distribute. So I'll get 5x plus 6x minus 21 equals to 23. This would be 11x minus 21 equals to 23. I'll add the 21 on both sides. Remember, we're solving for x. So that's going to be 44. I'll divide by 11 on both sides and I'll get x is equal to 4. Now, you got one solution. Now you got to find the y. So you grab this x that we just found and you plug it back into either the first or the second equation. Doesn't matter which one you choose as long as you choose the original equation. That is the key concept here. Always plug in. So always plug into original equation. So I'm going to use this second equation just because. So this would be 2. Instead of the x, we're going to plug in that 4. Plus y is equal to 7. So this would be 8 plus y is equal to 7. We'll subtract the 8 and we get y is equal to negative 1. So now we have the x and the y. Your solution's always going to be in an order pair. Remember, the order pair is always x comma y. So this would be your final answer to this problem. Again, it's always in an order pair. Now for this one, I'm actually going to solve for the x, just to show you guys that it doesn't matter which one you solve for first. Now I'm going to grab that x and plug it into here. So I would do 5 times 7y plus 11 plus 4y equals to negative 23. So this would be 35y plus 55 plus 4y equals negative 23. So that's going to be 39y plus 55 equals to negative 23. I'll subtract the 55. So I'll get 39y equals to negative 78. And then I'll divide by 39 on both sides. And I will get y is equal to negative 2. Now I'm not done. I'm going to go ahead and plug it back in. Again, doesn't matter which one you choose. I'm just going to choose the first one. X minus 7. Now it's going to be, instead of y, a negative 2 equals 11. So this would be x plus 14 is equal to 11. I'll subtract the 14. So I'll get x is equal to negative 3. Again, your solution is going to be negative 3, comma, negative 2. Now I'm going to go ahead and also solve, I'm going to solve for y in this case since it's by itself. So I'll get negative y equals to 6x plus 27. But I want to make sure the y is positive, so it's going to become y equals negative 6x minus 27. I just divided everything by negative 1. I'm going to go ahead and plug it into here. So I'll be 3x plus 8 times negative 6x minus 27 is equal to 9. So this would be 3x minus 48x minus 216 equals to 9. So I'll do 48x and 3x to get negative 45x minus 216 equals to 9. I'm going to go ahead and add 216 to both sides. And I'm going to get negative 45x is equal to 225. Then I'll divide by negative 45 on both sides. And I'll get x is equal to negative 5. Now again, I'm going to go ahead and plug it in. I'm just going to plug it into the second. So it's going to be 3 times negative 5 plus 8y equals to 9. So that will be negative 15 plus 8y equals to 9. Sorry, I'll add 15 and I'll get 8y is equal to 24. I'll divide by 8 and I get y is equal to 3. Again, your final answer is negative 5, comma 3. Now we're going to talk about the elimination method. The elimination method is when you add the x's with the x's and the y's with the y's and the constants with the constants. I always recommend you do ax plus by is equal to z. And then whatever you have at the bottom, I'm going to say ax plus by is equal to c. I'm using the same letters because the way you do this is you're going to cancel out the x's with the x's or the y's with the y's in order to solve for the other variable. So you multiply one or both equations by a number to result in the two equations that constant to opposite terms. So what does this mean? If 1a, let's say 1a is positive ax, you want the other one to be negative ax because that way they will cancel. We'll go over the problems to show you guys how it works. Now then you would add both equations and eliminate one variable, and you would solve for that variable, and then lastly plug it back in like we've been doing to get the other one. I'll show you guys with some examples. So using elimination method to solve for the system of equations, the first thing I want you guys to notice is that are there any variables that have already the same number or they're multiples of each other? In this case, we have the y's. We have one is positive y and the other one is also a positive y. They're both 3y's. So what I'm going to choose is I am going to choose to multiply this first equation by negative 1. The reason I'm going to do negative 1 is because I chose that I'm going to get rid of that 3y first because they're already the same number. I just need one to be positive and one to be negative. So this would become negative 5x minus 3y equals to 19. The other equation stays exactly the same. We don't do anything with it. We can just say, well, let's go ahead and add this. Negative 5x plus 8x, it's going to be a positive 3x. Negative 3y plus 3y is going to cancel to 0, y, or you can just ignore it and make it disappear. And then we have 19 and 25 being negative, we're going to get a negative 6. So we get 3x is equal to negative 6. I'll divide by 3 on both sides, and we get x is equal to negative 2. Now you do the same thing as you did last time. You grab that negative 2 of your answer and plug it back in, but again, into the original equation. So if I'm going to plug it into this one, let's say 5x, be 5 times negative 2 plus 3y equals to negative 19. Again, you always want to choose the original equation. So this would be negative 10 plus 3y equals negative 19. I'll add the 10, and we get 3y is equal to negative 9. I'll divide by 3 on both sides and get y is equal to negative 3. And again, your answer is going to be an order pair, negative 2, comma, negative 3. It doesn't matter if you solve for x first or if you solve for y first. You just have to make sure you pick a variable that makes sense. In this case, the y made more sense because they're the same number. Sometimes the x will. Let's see what the next problem is. Let's see if we solve for the y first or for the x. You notice for 5a, the y's are already a positive and a negative. So I'm actually just going to go ahead and add what I have. So this will become 6x. The y's are going to cancel out, so I'm just going to write 0y for the time being. And then I have 22 and 16. That's going to give me a negative 6. So this will be 6x is equal to negative 6. I'll divide by 6 on both sides and get x is equal to negative 1. If I were to do the x, I would just multiply one of them. But let's see as we move on if there's anything that we can do. For now, let's just go ahead and plug that 1 in. I'm going to plug it into the 2 times negative 1 plus 3y equals to 16. This will be negative 2 plus 3y equals to 16. I'll add the 2 to get 3y is equal to 18. We'll divide by 3 and we get y is equal to 6. So your solution is actually negative 1, comma 6. This is your final answer. Now, for this second equation, the y seemed like a great option. I'm actually going to multiply this top one by negative 1 to get rid of the y since they're both negative. So this will become negative 6x plus 5y equals to positive 8. I'm just going to go ahead and add. So it's going to give me negative 2x. The y's will disappear, so I'm just going to ignore it. And negative 4. I'll divide by negative 2 on both sides, and I'll get x is equal to 2. Now I'm going to go ahead and plug that number in, again, into an original equation. So 4 times 2 minus 5y equals negative 12. Again, doesn't matter which equation you choose, as long as you choose the original. Here we get negative 5y is equal to negative 20. I'll divide by 5 on both sides, and we get y is equal to 4. Your solution now being 2, comma 4. And then the last problem, we already have the x's that cancel out, so I'm just going to go ahead and add from there. We get 0x. Here we get 3y, and we get 34 minus 28 is going to be positive 6. Now I'm just going to ignore that term because 0x is just 0. I'll go ahead and divide by negative 3. And we get y is equal to negative 2. I'm going to go ahead and plug it back in. So I'm just going to choose the top equation again. It doesn't matter which one you choose as long as you plug it into the original. So we get 2x plus 18 is equal to 34. We'll subtract 18 on both sides. And that's going to give us 2x is equal to 16. When we divide by 2, we get x is equal to 8. So our solution is 8, comma, negative 2. Now here is kind of like what a multiple choice question would look like. They're asking us to solve for the system of equation. You can choose to do a substitution, elimination, whatever you want. I'm going to choose elimination. I am going to multiply by negative 3. Because that's going to get me the y's to cancel out. So I'm just going to rewrite the bottom equation first. And I'm going to get negative 3 times 5 is negative 15x. Negative 3 times negative 3y is negative 9y equals 2. And then 52 times negative 3 is negative 159. So I'm going to go ahead and add. The 15's happen to cancel out, so we get 0x. The y's happen to cancel out, we get 0y, and 159 minus 54 is just negative 105. Now we get 0 is equal to negative 105. Because this is not a true statement, 0 never equals 105. This will be a no solution. The only way it would not be a no solution is if we get a number. In this case, we don't get a number because they don't work out. And the way it would be infinitely many solutions is if you get a number is equal to itself. So if you get, I don't know, 100 equal to 100, that would be infinitely many solutions because that is a true statement. But for this equation, we get no solution because 0 cannot equal negative 105. That's just not a true statement. Here they're asking us again to solve for the system of equation. I'm going to go ahead and multiply by negative 3. Again, just to get rid of one of the variables, I'm rewriting the second equation first. So I get negative 3 times 2 is negative 6x. Negative 3 times 3 is negative y, and this will be negative 15. When we add them, the 6 and the negative 6x cancel out. The positive 9y and negative 9y cancel out, so we get 0 equals 2, and then 15 minus 15 is 0. This is kind of like the example I was mentioning before when a number equals itself. 0 equals itself. So this will be considered an infinitely many solutions. Now, this is kind of a summary of the different things that we have done in the 3.1. We have the table to estimate the solutions. The table will not be provided to an exact solution. You guys, we didn't go over a table, so don't worry about it. We've done graphing, substitution, and elimination. Now we did elimination by addition, we did elimination by subtraction, we did elimination by multiplication. By multiplication is just what we did in the last couple problems when we multiplied a number to be able to cancel them out. So we went over all of this. This is kind of a summary of all the problems. If you guys have any questions, I'll be back tomorrow for class and we can go over some of them. Keep in mind you guys do have homework. It is on Canvas already. If you happen to finish this in class earlier, you're more than welcome to get started. If not, please do it at home. I'll see you guys tomorrow.